Hello everybody. Today we're going to do a case study on a Ford Escape where the customer complaint is the air conditioning is not cold enough. To give you a little bit of background on this vehicle was in at a repair shop about 6 months ago. Apparently the compressor clutch failed in it, the electric clutch failed. So the shop went in and replaced the complete compressor assembly. Apparently that's the only way that you can get a clutch for this thing. Anyway, we got there to take a look at the car, and we went in, did the usual stuff, turned the air conditioner on to max, that sort of thing. And when we looked down at the clutch, the electric clutch, the clutch was actually turning. So the next thing we did was we threw a set of pressure gauges on it, and I'll show you the pressure gauges here in a second. But the pressure gauges literally showed that there was no difference in pressure between the high side and the low side, which meant that either we didn't have any refrigerant circulating through the system, or we didn't have a restriction in the system like a thermostatic expansion valve. And what I'm kind of talking about here is the expansion valve is a restriction in the system that lowers pressure from the high side to the low side, so there should be a pressure change across there. Then the compressor takes and increases pressure to pump the refrigerant through the system. So we've got one of two things going on here. Either we have no refrigerant flow, or we have an expansion valve that doesn't have a restriction in it. So we're going to kind of base our diagnostics around how we sort of approach this situation. So we started our diagnosis with checking the pressures. Now, I'll explain this a little bit. So we've got a gauge set hooked up. This is a 134 YF system. Not that that really has any bearing on what we're going to talk about here, but what you're looking at is the engine's running at about off idle, so 900 to 1000 RPM, and we have got the air conditioner turned to maximum cold. And you can see here, according to the gauge, we're going to use the inner blue ring, that both sides of this system are sitting at about 85 PSI. So that indicates to me that we have either no refrigerant flow or no restriction in the system. We then hooked the scan tool up to it to take a quick look at what the PCM was trying to accomplish here, what the PCM was doing. And very, very quickly, a couple of things here. There's no disable or inhibit conditions present. When we look at the ACC command up here, it is commanded on. So the PCM is acknowledging the air conditioning request. It has commanded the compressor on. When we take a look at our compressor duty cycle, keep in mind this is a variable rate compressor. I'll explain that in a second, but the computer is commanding a 73% duty cycle, which should equivalent to about 3/4 of an amp being applied to the control circuit. So I'm going to use this slide. This is a slide from one of our training programs, I believe, on automatic climate control, to very, very quickly recap how a variable displacement compressor works. This is really simple. There is a control solenoid which controls some of the movement, working on a piston to control the angle of this swash plate in here. The swash plate is directly tied to these pistons, which are the pumping pistons for the air conditioning compressor. So really, really simply here, as the control solenoid changes the angle of this swash plate back and forth, what happens then is we can basically increase or decrease the size of the pumping chamber, in effect controlling refrigerant flow through the compressor. So it's basically, or technically, it's a really simple design how it operates. And the key to this thing is this control solenoid. Now, none of this is serviceable, but really what you have to kind of pay attention to is this solenoid right down here. And we know from the scan data that the computer is commanding it. We just don't know whether that command is actually reaching down to the compressor or not. So I went and grabbed a wiring diagram just to kind of show you what we're doing. And well, I'll go over the electronics first, then I'll show you what we did with the scope to kind of verify what's going on here. So basically, the air conditioning clutch circuit is over here by itself, permanently grounded. The computer supplies power to it through an AC clutch relay. We know that's working because the air conditioning clutch is spinning the compressor. And then this is the solenoid that I was talking about. Now this solenoid is fed battery power through a 10 amp fuse 34 here. And then the powertrain control module pulse width modulates the ground to change the angle of the swash plate to control compressor operation. This is the scope hookup we used. So we used a low amp probe on the control wire, and we didn't go down to the compressor to do this. We grabbed it at the powertrain control module for the simple reason that if the circuit's good all the way through and current's good going into the compressor, or sorry, going into the PCM, then we know the rest of the circuit is intact. And so that's our green trace. And then our blue trace is the control solenoid, which is the pulse width modulated circuit. So this is kind of what it looks like on a scope. Now I have a bigger look at this. So here you can see the current on the solenoid is around 3/4 of an amp. This is 0.5 amps. This is 0.9 amps. So it's obviously being pulse width modulated a little bit here. Here's our control signal down here at the bottom. So you can see that the computer is doing the right thing. It's pulse width modulating the circuit. The circuit is drawing good amperage, pretty much on par with what the computer is asking for. So this means that that solenoid is being driven correctly, and therefore this compressor should be almost in the full on position, which means we should have good refrigerant flow in the system. So to recap where we're at, basically at this point we've determined that the compressor is being commanded correctly and that we either have no flow or no restriction. Now our experience when it comes to expansion valves that are stuck open for whatever reason is if you can get enough refrigerant flowing through the system, you can get a slight pressure imbalance between the high side and the low side. That's clearly not happening here, even though the compressor is commanded pretty much to the full flow position. Therefore, our conclusion on this one is that the compressor isn't really pumping refrigerant. That's the reason for the no change in pressure across the expansion valve. So we went ahead and called it for a compressor, had the client install a compressor, and the vehicle's been cooling properly ever since. So the bottom line on this one was it had a bad compressor, and it wasn't all that hard to diagnose, just having the right tools and that kind of stuff. So I hope you enjoyed this case study, and keep an eye on our website and we'll keep posting them. Thanks a lot, guys. If you like this video, please let us know by following us or liking us on Facebook, Instagram, Twitter, and YouTube. And if you want access to more in-depth training videos, please visit our website at www.autoaide.ca. Thanks for taking the time to watch this video.